Hello, my beautiful students, and welcome to Module 2. In Module 2, we talked about greatest common factor and least common multiple. They're also known as GCF and LCM, and mainly we use them a lot with fractions. When we talk about greatest common factor, we want to know how we can group things. So we can remember that with G, grouping, G, greatest. So the greatest common factor, also starting with the letter G, is for grouping. The definition, let's start there, of the greatest common factor is the largest common factor, that's where you get greatest and factor, common factor, of two or more given numbers. So for example, if we have the numbers 12 and 18, and we want to know the factors of 12 and 18. Let's start with the factors of 12. The factors of 12, remember I told you guys to always start with the number 1. 1 and what number will give us 12 is 12. We go on to the next number. Does 2 work? Well, 12 is an even number, so we know that 2's got to work. 2 and 6. And lastly, what two factors will give me 12? 3 and 4. Now, if we think about this, we did 1 and 12, 2 and 6, 3 and 4. The next factor would be 4, and we're going backwards, so we know that we now have all the factors of 12. And now we go on to the factors of 18. Factors of 18, again, starting always with number 1, 1 and 18. Will 2 work? Well, yes, 18 is an even number, so 2 and 9. 3 and 6. 4 will not work. 5 will not work. 6 will, but remember now we're going backwards. So the greatest common factor between 12 and 18, well, let's see. We have common factors of 1, 2, 3, and 6. But the greatest common factor would be 6. So when would we use this in the real world? Let's take a look at a real world example involving greatest common factor. There are 12 boys and 18 girls in Miss Taylor's science class. Well, the fact that there are 12 boys and 18 girls is important, necessary information, so I'm going to circle that. Each is important. Each lab group must have the same number, that's important as well, of boys and the same number of girls. What is the greatest number of groups that Miss Taylor can make if every student must be in a group? Now, this is where GCF comes in really handy because we don't have an equal number of boys and girls. However, we can create groups that will have an equal number of boys and girls in each lab group. So, we would start with, let's think about the factors of 12. That would represent the boys. So I'm just going to put a B next to it. That represents the boys. Always starting with the number 1. So 1 times 12 will give me 12. 2 times 6 will give me 12. 3 times 4 will give me 12. And then 4 times 3, we're going back, so we have all the factors of 12. Moving on to 18, there are 18 girls in this class. I'm going to put G for girls, and we always start with 1. 1 times 18, 2 times 9, 3 times 6, 4 will not work, 5 will not work, 6 will, but we're moving backwards, so we have our factors of 12 and 18. Common factors are 1. Common factors are 2, 3, and 6. Now, what this tells me is that there are going to be 6 groups But to go further, let's think about how many boys would be in each group and how many girls would be in each group. Because remember, we don't have an equal number of boys and girls in the class. We only have 12 boys. And if we have 6 groups, 6 times what number? Well, let's go back to where we connected it. 6 times 2 is 12. So there are going to be 2 boys in each of the groups. And let's do the same for the girls. So we know there are going to be 6 groups. And 6 times what gave me the total of 18 girls? 6 times 3, and that's where we were. So there are going to be 3 girls in each group. So even though there are going to be 6 groups, because there's not an equal number of boys and girls, you're going to have less boys in each group than girls. Clearly, because you have less boys than girls. But in this case, Miss Taylor's science class is assured that each group is going to have the same number of boys and girls in each group. Now, how are we going to remember GCF? Well, GCF stands for greatest common factor. And the way that we find the factors is we connect friends. So gonna connect friends, GCF, will remind me greatest common factor because you're connecting friends, you're connecting factors. And this will help you determine the difference between GCF and LCM. Let's take a look at another real-world example of when we would need to use GCF. I hope you remember that I shared with you that my brother is a floral designer in New York City. And as a floral designer, his job is to create bouquets and flower arrangements for businesses and for personal use. Let's take a look at this example. A florist makes bouquets from 18 roses and 30 tulips. All the bouquets will include both roses and tulips. If all the bouquets are identical, that means they're exactly the same. What are the possible bouquets that can be made? Now let's think about this because remember I told you guys that my brother takes his job very seriously. So he doesn't want to make any mistakes. And if he has someone that's asking him for arrangements that have equal number of roses and tulips, they don't want any mistakes. So they don't want a bouquet that has more roses than tulips and vice versa. So how are we going to make this happen? Remember that GCF deals with grouping. So we're going to take a look at the 18 roses. And I'll put the R for roses. Let's start there. Remember, always starting with the number 1 times 18, 2 times 9, 3 times 6. 4 is not going to work, 5 is not going to work, 6 will, but we're going backwards, so we have all the factors of 18. And what you're going to notice is the more and more that you do this, the more familiar you are with the factors and the easier this becomes. Let's now take a look at the 30 tulips. And we'll find the factors of 30. So we have always starting with the number 1, 1 and 30, 2 and 15. Remember we talked about the importance of knowing your factors of 15. It's just like knowing your factors of 12. You should know your factors of 15. 3 times 10 will work. 4 times nothing gives me 30, but 5 times 6 will work. And then we have 6 times 5, but we're moving backwards, so we have all the factors of 30. Now let's see what common factors we have. They have 1 in common, 2 in common, 3 in common, 6 in common. Anything greater than that? 9, no. 18, no. So in this case, my brother would make 6 bouquets, and each bouquet would have, well, 6 times what was 18? 3 roses in each. And each bouquet is going to have 6 times what gave me 30 times 5. It's going to have 5 tulips in each bouquet. So notice how this really came in handy in a real world situation. Now let's move on to least common multiple. The definition of a least common multiple is the least number that is a multiple of all the numbers. Now notice the key word here is multiple. It comes from the word multiply, and when we multiply, we are getting bigger. The numbers are getting larger. So when you think about least common multiple, even though it sounds like an oxymoron, it really is not. Just think about the multiples, and then we're going to choose the number that they have in common that is the least common multiple. So here we go. Let's think about the LCM of 6 and 8. Multiples of 6. So now we're not thinking factors. We're not thinking those little numbers that combine together to give me a product. Now we're thinking multiples, how we get bigger. So 6 times 1, 6. 6 times 2, 12. 6 times 3, 18. 6 times 4, 24, and so on. So what we're doing with multiples of 6 is we are just getting bigger. So multiply it times 1, 2, 3, etc. So multiples of 6, 6, 12, 18, 24, 36, 48. Multiples of 8 are 8, 16, 24, 32, 40, and 48. Now, we can take a look here and we can see that we actually have 2 common multiples. We have 24 and 48. But the least common multiple would be 24. So in this case, the LCM of 6 and 8 is 24. Let's take a look at LCM using a real-world example. Ned is training for biathlon. He will swim every 6th day. That's important information. And he's going to bicycle every 8th day. On what days will he both swim and bicycle? Well, when we were talking about GCF, we were talking about grouping. LCM is different. Least common multiple is more for when 2 things are happening on different dates and you want to know when they're going to end up happening at the same time. So if, for example, in this example, Ned is training for a biathlon, he swims every 6th day. Well, that means he's going to be swimming on day 6, on day 12, on day 18, on day 24, on day 36, on day 48, and so on. It also tells us that he's going to bicycle every 8th day. So on day 8, day 16, day 24, day 32, day 40, day 48. Now, on some of these days, he will be both swimming and riding his bicycle. And that's basically what they're asking me to do. So with LCM, we are looking for those days that specifically tell us when he's going to perform these 2 activities on the same day, not at the same time. So let's do multiples of 6. So we have on day 6, 12, 18, 24, 36, and 48, he's going to be swimming. And then on days 8, 16, 24, 32, 40, and 48, he's going to be riding his bicycle. So we want to know on what days he's going to be doing both. Well, the 6 doesn't match up, the 12 does not, the 18 does not. But check this out, the 24 does. So on day 24, he's going to be swimming and riding his bicycle. And also on day 48. Now, even though that this happens at multiple times, if they're asking us what is the soonest date that he will be both swimming and bicycling, then the answer here would be 24, and that would be our least common multiple. If, however, they want us to keep going, we very well could keep going with multiples of 6 and multiples of 8 and determine on what days he will be doing both activities on the same date. Now, it just so happens that for this example, the least common multiple is day 24. So on day 24, Ned will be training for the biathlon, and he will be both swimming and riding his bicycle. And how are we going to remember LCM? Well, we're going to remember it with ladders can multiply. LCM refers to numbers getting bigger, and as you're going up the stairs, just think about going up your multiples of 6, 12, 18, 24, multiples of 8, 16, 24. Now let's try to take a look at a real-world example, another one with LCM. In this example, we have a store and they're holding a promotion. And every third customer that comes in is going to receive a free keychain. And every fourth customer is going to receive a free magnet. So we have 2 pairs of customers here receiving free items. If you're every third customer, you're going to receive a free keychain. And if you're every fourth customer, you're going to receive a free magnet. Now the question asks, which customer will be the first to receive both a keychain and a magnet? Again, 2 events happening at different times, but eventually, if you are the third customer at this store and you go in there frequently, you very well could also be the fourth customer that receives the free magnet and also be the third customer that receives the free keychain. So let's see how that's possible. We're going to do multiples of 3 first. So every third customer is receiving a free keychain. We have customer 3, the 6th customer is getting a free keychain, the 9th customer is getting a free keychain, the 12th customer is getting a free keychain, the 15th customer, the 18th customer, the 21st customer, and I will end with the 24th customer because I can go on and on and on, and hopefully this is a store that is thriving and flourishing and has many customers. Now let's take a look at the customers who are going to receive the free magnet. The customers who receive the free magnet are every fourth customer. So customer number 4, customer number 8, customer number 12, customer number 16, customer number 20, customer number 24, customer number 28, and we can stop there. So we want to know which customer will be the first to receive both a keychain and a magnet. So let's see if we have the least common multiple here. Well, 3 doesn't match up, 6 does not, 9 does not. Oh, there it is. So the 12th customer will be the first to receive both the keychain and a magnet. Well, this concludes our review on module number 2, GCF and LCM. Any questions? Please feel free to ask, and I can't wait to get with you for module 3. Bye!